We continue our pointer discussion. We'll discuss dynamic memory allocation and functions that return pointers. Don't forget this rule for dynamic memory allocation. You allocate memory, you use the pointer that has that memory, and you must deallocate the memory. So thus far we've been creating a variable, and then we've been creating a pointer that stores the address. However, we can also create memory dynamically, and we don't have to create a stack variable. We create a pointer, and we can say number equals new int and 15. And we can use it. In this case, we'll simply display it. So we allocate memory, we use a pointer, and then we must deallocate memory. We use the delete keyword, number, and we must point to an address of 0, which is usually an address reserved for operating systems, and it's read-only. Thus, we will not be harming anything in our program. So if we don't deallocate memory, so if we don't deallocate memory, we have a memory leak. That is, there'll be other statements of code here, and program will continue running. If we have too many situations where we allocate memory and not release it, then eventually our program will suffer and crash. If we deallocate memory but don't clear address contents of pointer, we have a dangling pointer, meaning if we say delete number and we don't say number equals 0, then we have a dangling pointer, and that's not good either, because our program will produce incorrect results. Always remember, deallocate memory and clear the address contents. The next use case is for an array. If we have, for example, some method that reads data from file, this is just a very simple example, and logic would be in here to read data from file and say it returns something, right? That file has 10,000 records. That really doesn't matter. So we can create an integer size and call read data from file, and then we can create a numbers array, and we can say new int of size, meaning create 1,000 records, right? And we can say for integer I equals 0, I less than size, I plus plus. We simply say numbers of I equals I for now. Let me see. And then we say for integer I equals 0, I less than size, and now we want to count numbers, right? Maybe we shouldn't say 10,000, maybe we should say 10 over here, right? We run this program, and there it is. So we create array dynamically. What didn't we do? Deallocate memory. So then we say delete, it's an array, we use open close bracket, and then numbers equal 0. So now we go ahead and run our program, and we've deallocated the memory. So we allocated memory for an array, we populated the array hypothetically, we used it, we deallocated the memory, we called delete, and we set the address to 0, and that was to prevent memory leak or a dangling pointer. We can also return pointers from functions. For example, let's say that this function calls for returning a pointer. So now we will say size equals new int and whatever, right? Of 10. Of course, here there will be some logic to read the file, but we're not going to do that. And then we return the variable and we have to create a pointer over here, and we have to dereference the pointer, dereference the pointer here. We created the pointer over here, however we are going to deallocate the memory here, so we say delete size and size equals 0. We don't want a memory leak and we don't want a dangling pointer. So you see, sorry, I missed this one. So we run our code, and that's how we can return a pointer from a function. It is very important that we deallocate the memory. We can't deallocate it over here. We deallocate it in the colors scope. Scope. And for now, that's all I wanted to discuss on this video, and that's it for this video.